Good evening once again. So today we will be holding our fourth IR session. Apologies for the fact that we couldn't hold the IR session last week due to some unavoidable circumstances. The date is yet undecided, but we will soon hold the IR session on Joy. But today's kind of special because for the very first time a second year has come up and said that yes, I want to hold an IR session. So yesterday we mentioned this week and in fact the next week a second year student again will hold the IR session. So it's a really good thing that the second years are coming up and saying that they want to hold an IR session. And who else if they need to strike a mind and start the IR session the second year, it has to be Debdatta. So without any further ado, I would invite Debdatta to start the IR session. And according to her preference, that if you have any sort of questions in your mind, you can straight away ask the questions. Just raise your hand and ask the question. And if the video is posted later on the YouTube section, then you can ask questions on the YouTube comment section. This topic is quite intriguing as well. Means for me, it's quite interesting because I'm a Marvel fan, and in Marvel, I think in the Avengers Endgame there was a suit. Iron Man made a suit Mark 50, so it was fully developed with the nanobot. So I don't know whether it has progressed to that limit or not, but if it has, I think it's very commendable. So for me as a Marvel fan, I'm quite forward to that. So best wishes.
Thank you, Shomala, for introducing me so nicely. And am I audible to everyone? Good evening, ma'am. Good evening to everyone present here. So, today I have taken a topic, as you can see, biggest problems can have smallest solutions. In today's world, we are faced with so many problems. Pollution, people are getting sick everywhere. So, we need to find a solution to all these problems. So there is one approach, which is not one approach, a branch of science called nanotechnology, which has some probable solutions to many such problems. Before we begin anything about nanotechnology, we must understand what the word actually means. So if we break up nanotechnology into two parts, it is nano and technology. So what is nano? Can anyone tell me what is nano? What is nano? Sorry? Sorry?
Ma'am, I know.
Okay, so we calculate that nano is 10 to the power. So nanometer is 10 to the power minus 9 meter, which is 1 billionth of a meter. Words. And can anyone define technology for me? Can anyone for me? It is very simple. I want everyone to it. I want it to be very interactive. So what is technology? It's the word. It's a word we use every day, right? Anyone? Anyone? Please.
Technology is where we basically apply all that we know about science to into application into to ease human lifestyles.
Excellent. The technology is application of science in practical field to ease our lives. Okay. So before going further, I would like to give an illustration about how small one nano is. Dr. Nasuri is a researcher in Macquarie University, and in one of her TED Talks, she gave this beautiful illustration. Here we can see 1 meter is the size of a baseball bat. A baseball bat is not something we see regularly, so we can imagine a meter scale, right? 1 meter is the size of a meter scale. You divide it by 10, you get the size of your fingertip. You divide it by 10 again, you get the size of a needle head. And you divide it by 10 again, you get the thickness of your hair. till now, we were in the world which we can see through our naked eyes. Let's divide this by 10 again. We get the size of one blood cell. Dividing it by 10 again, that is the size of a bacteria cell. Now again, we are dividing it by 10, that is the size of a virus. We have entered the nanoscale already, it's 100 nanometer. And then 1 nanometer is almost the length of half DNA. So yes, that small is 1 nanometer. What is nanotechnology then? Nanotechnology is essentially application of nanomaterials or particles in the order of nanoscale in practical field. So here we have taken a couple of formal definitions. Wikipedia says nanotechnology is the use of matter on an atomic, molecular and supramolecular scale for industrial purpose. I have collected another definition that says nanotechnology refers to the branch of science and engineering devoted to designing, producing and using structures, devices and systems by manipulating atoms and molecules at nanoscale. Let's look into the history of nanotechnology. Who was the first person to introduce the idea of nanotechnology as such, the concept? So anyone knows or anyone wants to guess? The first person to introduce the concept of nanotechnology? Sorry? Exactly. In his talk, there is plenty of room at the bottom. In 1959, he introduced the concept of nanotechnology. There, he talked about getting the whole 24 volumes of Britannica Encyclopedia in the head of one needle. It's an extremely interesting talk. I also recommend people to go on YouTube and listen to this talk. After 15 years, it was in 1959 he introduced the concept, and after 15 years, in 1974, the term was first coined by Norio Taniguchi. I may be wrong with the pronunciation. He was a researcher in the Tokyo University of Science. He said nanotechnology mainly consists of the processing of separation, consolidation, and deformation of materials by one atom or one molecule. Maybe the first practical approach of nanotechnology or the practical beginning to nanotechnology started in 1981 with the invention of scanning tunneling microscope. And for that, Gerd Binning and Heinrich Schroer, the inventors, they were also awarded with the Nobel Prize in 1986. So with nanotechnology, we come to another question, that what are nanomaterials or nanoparticles? By definition, as you can see here, nanoparticles have size ranging to 1 to 100 nanometer. Let's look into how we can prepare nanomaterials or nanoparticles. Essentially, it is very easy to think that when we are preparing nanoparticles, we can either come from the bigger to the smaller, or we can go from the smaller to the bigger. So when we are coming from bigger to the smaller, that is called when we are going from the smaller to the bigger, it is called bottom-up approach. And when we are coming from the bigger to the smaller, it is called top-down approach. So in these approaches, what we are doing is in top-down approach, we are taking a bulk material. We are digging it up until we get nanomaterials. In bottom-up approach, what we are trying to do is we are taking atoms or molecules. They will form clusters, and then we can form nanomaterials. So here is again another question to the audience. Which method should be more useful, or which method is more favorable? Anyone, any guesses?
Bottom up,
Of
more
course.
flexible.
So essentially,
Bottom up approach is more flexible because you get the freedom to choose how you want to construct it, like making a vase from clay.
also when we are going from bulk to nanomaterials, We don't get very smooth surfaces. We produce a lot of waste. So that is less favorable compared to bottom-up approach. Now let's come to types of nanoparticles. So we have synthesized nanoparticles. Though I just touched upon this topic, let's talk about types of nanoparticles based on their size. We have zero-dimensional nanoparticles. So zero-dimensional nanoparticles are particles whose all the dimensions are less than 100 nanometer. So can you guess what shall be the shape of such nanoparticles? Anyone? All the sides are less than 100 nanometer. All the dimensions. X, Z, and Y axis, all are less than 100 nanometer. So what can be the probable shapes, roughly? Sorry? Dots. Yes, they will have some symmetric kind of structure that can be cubic, that can be dots. So some examples of certain nanomaterials are fluorine, carbon quantum dots,
শেষ
etc.
করছে বল
Let's move on to 1D nanoparticles. If we move on to 1D nanoparticles, it's easy to understand that 1D nanoparticles, one dimension will be greater than 100 nanometer. So what can be the probable shape? Two dimensions are again less than 100 nanometer, but one dimension is greater than 100 nanometer. Sorry? Anyone please? Yes. I'm sorry? Helical can be a shape, but I think it's very difficult to create a helical nanomaterial as such. Yes, exactly. Rods and wires. That will be in the form of rods and wires. Now, for 2D nanomaterial, I want someone from the audience to define 2D nanomaterial now. Because I've already shown 0D, 1D. It's very easy to understand what should be the definition of 2D nanomaterial. Louder, please. Exactly. In two dimensions, the nanomaterial will have size greater than 100 nanometer. So that shall be the shape of sheet. We have several. This is a picture of a graphene sheet, and these are some examples. And what should be the shape of a 3D nanomaterial now? It can be anything actually, because all dimensions it is crossing 100 nanometers. It can be a big sphere, a big cube, anything. So this is a picture of a 3D nanomaterial. Now I have a question which is solely for the second year, not for the subsequent. If we have some metals like iron, gold, copper, silver, let's have some metals. Iron, gold, copper, silver. And we are trying to form nanomaterials from these metals. So which metals form nanomaterials in their zero oxidation and which metals should form nanomaterials in their oxide state? I want people from my year to answer because it's simple chemistry, very simple, 10 standard chemistry. What copper for what? Zero oxidation. Oxide. Okay. So copper oxide. Copper oxide. Others. Gold will be metal state. Zero oxidation. And the other. You're going in the right direction. I will go in the oxide state. Any other suggestion for future? Anyone else from other years as well?
Hmm. Silver is not useful.
Anyone else? So I want to answer this. What is the answer? I wanted to show a picture here. Zero. Okay, that's correct. For stable metals that do not tend to form, cations, they will form nanomaterials in this metal state. And for metals like iron and copper, they will form oxides. They will prefer to form oxides in their when we are trying to make nanomaterials from them. By now we have seen what is nano, how much small 1 nanometer is. We have also tried to understand what is nanotechnology. We have learned a bit about nanomaterials or nanoparticles. What are they? What are the types? How we synthesize them? Now, can someone tell me why we want to learn nanotechnology? What is the need? What is the need of trying to synthesize nanoparticles? Where scientists and researchers from every arena concentrating on synthesizing of nanoparticles, several kinds of nanoparticles. Why is it so much in demand? Why is it so much growing field of science? I want inputs from, or rather, if I simplify the question, or if I break the question, why are nanoparticles special? Why are they different from bulk? What are the things we can achieve from them? Can you repeat your answer? Large surface area, right? We can also modify it and write large surface area to volume ratio, right? Next. I also want my seniors to answer. I know they know a lot more than me. I don't know much, but what are the other things that make them special? Or any other characteristic? Sorry? I quantum physics. And someone said it's more portable. Who said that? Any other inputs? Anyone from any year? Anything it can be. Nanomaterials, we know they are inherently of very small size, right? So what are the good effects of having something very small?
Well, since you have very small particles, you can essentially combine them, layer them, arrange them in any order which you want. And you can also essentially construct very sensitive scale experiments for that. And also, you can take advantage of point number two, quantum effects.
So what is the point in short that
Like, point in short is that it is very versatile to use. Versatility is extremely high.
we have any other input? So let's think that when we, suppose any of you wants to buy a car, so you can buy any car, and suppose you have chosen to buy nano car, you all know about the brand, right? Nano car. So why would you prefer to buy a nano car over any other car? Space, right? So because if we talk about our country, it's a busy country, the roads are busy. We would prefer a car which is small, penetrate through that busy roads, right? So, and also another thing that makes nano cars more preferable is it is cost effective, right? So we can also add 2 points. It is not cost effective, not always, but sometimes synthesis of nanomaterials are actually cost effective. And because of their small size, they can pass through cells, cell walls, cell membranes, right? Suppose you want a nanomaterial to pass through your vein. You can't have a big bulk material. You can't introduce a bulk material into your veins, right? You need a nanomaterial for that. So we must understand one thing that nanotechnology is not solely about creating nanoparticles. It is about understanding the science that they follow. They do not follow the science of bulk materials. The gravity will not have same effect on this chalk and on a nanomaterial. It's easy to understand. Many effects, many like quantum effects, it comes into play. Can you guess the color of gold? A nanomaterial, nanoscale. Can you guess the color of gold? Shall it be gold anymore? What can be the color? Just guess. Just for fun.
Does gold become something of silver colored when it gets broken down into nanoparticles?
As far as my knowledge is, it ranges from red, purple, or it can also be green at a very small scale. Now let's see how these very small objects are actually solution to really big problems. Here you can see this picture is of a breath analyzer made up of nanomaterials. Breath analyzing is not something new to us. At night, when you are driving, you can be stopped by a police who would analyze your breath for alcohol, right? So breath analyzing is not new. But do you know that we smell different even when we are sick? Have you noticed that dogs, they smell us more when we are sick? If anyone has pet dogs here. Or have you seen that dogs smell each other very keenly? So dogs, they can sniff when we are sick. They can understand that by our breath or by the smell. So when we are sick, our body releases some biomarkers, but they do not release the biomarkers in large quantities. So it is not possible for a human or for a dog or for any normal breath analyzer to detect such low concentration of biomarkers. For that, Dr. Nasiri, she is Dr. Nasiri, whom we also spoke about at the very beginning of my presentation. She has invented a nanomaterial, not a nanomaterial, sheet which is made up of millions of nanoparticles of zinc, nickel, and other metals. And with that, and that has a very high surface area, so it's very sensitive, right? So that can detect the biomarkers in our brain. Let us talk about diabetes. What happens in diabetes? Anyone from the audience? What actually happens during diabetes? Anyone, please? Okay, so insulin is not secreted. Or insulin does not bind to glucose. There can be 2 types of diabetes. If insulin is not effective, what happens is the body doesn't get energy because it cannot break down glucose. If it is not getting glucose, if it cannot digest glucose, it will not get energy, right? So what our body does, it breaks down the muscles and fats in our body. And what is formed as a result are ketones. And if the concentration of ketones in our body increases, that can be actually fatal for us. Now, to detect diabetes, we already have blood tests and everything, but this nanotech thing device that will help to detect diabetes even at a very low amount. It will detect minimum to 2 parts per million. Can you imagine the so low concentration of ketone can be detected through this device? So you can can also ask what is the utility of this when we have blood test, right? Any answer for that? I want other people to answer as well. We already have blood tests for detecting diabetes. Why do we need such a device that can detect diabetes through our brain? Sorry? Sorry. Method reduction. Better detection. I want a bit of more detailed answer. Not more detailed, but can someone elaborate on that?
One can identify the diabetes with help of blood test. In the blood amount of glucose will be in. That you will get you do it with the help of nanoparticles. And this problem I want to say that if we want to detect the test in the blood test, then I think that in the blood the amount of glucose should be more. But if we do it with this technology, this problem is
I don't know if correct, but my answer to this, or in fact, her objective of designing this, a lot of people, they also have several children, they suffer diabetes, they will be reluctant to do blood test. But a very good thing about this device is it can also detect pre-diabetic condition. So imagine, if we can detect pre-diabetic condition, we can stop the patient from going into diabetes, right? So that will be a game changer in this whole image. There are countries like Singapore, I think, where 1/5 of the whole population suffers severe diabetes. That is not desirable. So this device, using this device, as I said, it can detect very low concentration of ketone in our brain. So it will be able to detect a pre-diabetic condition, and which will, and if we now change our lifestyle, we can actually not go into diabetes. No, you will just breathe on it. You will just breathe on it, and it will detect the ketone from your breath. It is not invasive. Yes, it's. No, there's no scene of blood here. There are people like Ishita who are very scared of needles. So most of the people are scared of needles, correct? Okay. If you want needles, okay. So you will share and remember this. Yes, Girish needs donors for blood group testing. Now, let's look into how can we treat diabetes using nanomaterials. We now know how can we detect diabetes by use of nanomaterials. Now, say you already have diabetes, there is no point in detecting it, but you want to treat it. There are treatments of diabetes, right? The most common thing is, or the most used treatment is to inject insulin in our blood. So this is available from market, not now, but it should be. And I've given 3 instances of application of nanomaterials which are in the research stage. Not yet, but I think it has a patent on it. So let's talk about treatment of diabetes. We can't take insulin orally, right? Why? This is a question for second year people, and it's a very 10th standard question. It will? No, why? We can't take insulin orally. We can't take it in form of medicine. We must inject it for an effective treatment of diabetes. Why? What is insulin? What is insulin? It is a protein, right? And we know that our stomach has the ability to digest proteins. So if we take insulin orally, stomach will digest insulin, and it will. We want the insulin to be present in our bloodstream. This is not absorbed. It will not be absorbed in our blood, as Joydipta already said. It will not dissolve in blood if we take it orally. For that, Nanotechnological University, not only that university, this research is going on in several other universities across the globe to create nanocarriers that can be taken orally, and that should that can replace injection of insulin. Right. So how can you synthesize this kind of nanomaterials? How Nanotechnological University synthesizes this is they injected insulin inside a liposome sphere in the nanostrip. So, and they coated it with several layers of insulin and chitosan. This coating, the number of layers they are using for coating, the dosage of insulin required by that patient. So, of course, you can say that it is still going inside our stomach. The insulin should dissolve anyway. But what happens is the external layers of insulin, yes, some of it, you have a question. Sorry? The camera is that side. Okay, so the layers of insulin and chitosan, the insulin do dissolve in our stomach, but not all of it. It has been experimentally found that only 6% of insulin dissolves in our stomach, and the rest, the amount of insulin inside the liposome, that remains intact till it reaches intestine. And the layers, some of it degrade and some of it don't. So by, you have to know the amount of insulin a patient needs, and then that number of layers are made. So through intestine, this insulin enters the bloodstream, just like other food material does. So this is a very effective method if we consider, we all have old grandparents or any other old relatives who stay alone, and it's very difficult for them to inject insulin on themselves. So this is a very effective method. That will get deposited. No, that's why here it is made essentially only of organic ribosomes, liposomes, and they are all organic. I think that important to be putting on the I'm addressing question. Here's my knowledge. I'll try to address it. Thank you all for this question. We have talked about nanoparticles, nanomaterials, and now we will talk about nanobots. What are nanobots? I would actually like to. Nanobots. It is easy to conceive the meaning from the word itself. We already know what nano means. Sorry? Exactly. Exactly. They should be capable of self-propulsion because that is the inherent criteria of having a bot. They should be capable of self-propulsion and they should have some kind of autonomy. Here we see a picture. This picture is of a water body which is very badly affected by dyes. Water pollution itself is a very serious issue in this current world. Water pollution is a very serious issue, and dyes they contribute greatly in water pollution. To solve this problem, several researches are being carried on. Several researches are being carried on. Now, if you want to solve this problem, definitely there are many other ways instead of using nanotechnology. But can you tell what advantage nanomaterials or nanobots will have over other bulk materials? Okay, good surface area. Main thing is we don't want to introduce another bulk material into this water body and make it more burdened, make it more polluted, right? But we must remember that there is aquatic life inside this river. The organisms, the fishes and everything, they can be disturbed by the bulk material, right? If you are introducing it in this water body. So if you're doing it with help of nanobots, nanobots are objects, as I said, they are capable of self-propulsion. We can use nanobots that if we leave it on the river, they will be able to move across this whole water body, if not whole a part of it, on itself, and it should be able to degrade the light. What should be the inherent criteria of nanomaterials that we will be using to solve this problem of water pollution? What should be the characteristics, the features of the bots? Sorry? We are using nanomaterials, nanoparticles. What should be their features? What are the criteria? Or rather, what nanomaterials we should not be using to reduce pollution? Sorry? So it should be specific in nature, should not contain heavy metals. Okay, so I was also looking for these points. We can't synthesize a nanoparticle which will have metals in it which themselves will create pollution. Right? We must have something which are compatible with our environment. That researches are going on, and nanobots have been synthesized using carbon dots and iron oxide. We know that carbon is something compatible to the environment, and iron also it is not very incompatible to the environment. Coming to carbon dots, can you say where we see carbon dots every day? Not every day, but in a very common basis. We see it in a common basis. There are a few people who know about it. I want others to answer. Carbon dots, we see it in a daily basis. If not daily, we see it commonly in our house itself. Or can you just guess? Carbon, you can find it, it's present in every food here. So, kitchen, the bottom of the right. This is this bread. So these particles, because of these black particles, they are nothing but carbon dots. Anyone would like to try this? Yes, this is anyone would like to practice? Yes, exactly. I was just going to come to that point. It is highly carcinogenic. That's why we should never have over toasted breads and things. So these are inherently carbon dots. In lab, at least in the lab I worked in this last summer, carbon dots were using an organic. It's very easy to comprehend now that they can be formed easily using organic things. Any question? Okay. So what was done was potato peels were used. It's a household waste, very easy to find. Potato peels were dried, crushed, and they were pulse heated in the micro oven, and they produce these carbon dots. These carbon dots are so it is very cheap in nature. You just need to mix some amount of ammonium hydroxide, and it's very cheap. It's actually nothing much. And then iron was used, iron oxide rather. So what happens when after the bot is synthesized is that iron 2 plus will convert to iron 3 plus. We know it readily will like to do that, and this OH radical is released. Okay, before that, I would like to say that we need to add some amount of H2O2 in the medium if we want this bot to prepare. Okay, so from H2O2, This iron 2 plus can readily synthesize OH radical, and this OH radical reacts with the dyes also. And another important feature of this iron 2 plus degrading H2O2 is that all the H2O2 will gather on its surface, and it has a great surface area, as someone we discussed about it before, like nanomaterials have greater surface area. So the bubbles will gather all around its surface. There will be many bubbles gathered on its surface. The bubbles will join to form bigger bubbles, and then the bot is propelled forward. Here is a reaction coordinate graph. We can see that this is the one with greater activation energy amount is the amount of energy required to synthesize OH radical without the nanobots. And you can see so much that the energy is reduced so much when you are using a nanobot, right? So very readily a nanobot will degrade H2O2 and form OH radical, and that OH radical degrades the dyes, and also it helps the bot to move forward. Here is a image of a bot. This is not a very good bot. In fact, this is not a nanobot. This is in the range of micrometer maybe, and this is seen under microscope, and these are the bubbles. Okay. So with that, I would like to, these are the three applications of nanotechnology I had in my presentation. Also, nanotechnology is used in other fields as well, which they are used. For example, in cosmetics, we have wide use of nanomaterials, silver in form of nanomaterials. You all must have seen that. So with this, I would actually like to end my presentation. And I would ask every one of you to think that after 30 to 50 years, when these experiments, these researches, they come into reality, our lives will become much more easier, right? But with that, some complications will also come because nothing comes only with pros, right? Everything has some negative points. So with this, I'd like to end my presentation. And if you any of you have some questions, please don't hesitate to ask me. I will try to answer all of them. And thank you everyone for. I can actually show a video. I would like to. Sorry? I would like to show a video in that regard. I'm just stopping my Google Meet presentation for a while. I'll turn it on again. None. No, actually, I tried to put this video in my presentation, but I could not for some technical issues. I'm not actually being able to show the video right now for some technical issues, I think. No, I did not want to show the video, but as this question came up, I'm thinking. No, it's having some problem. That's why I eliminated it from my presentation. মেলটা খুলে দেওয়া যাবে। Eta. अच्छा. Okay, so this is the video. And if you have seen, you can see the bubbles have gathered here. Take the video from the screen itself. It is yes, it is taken from the screen of the computer to which the microscope was connected. No. It is my work in this last summer. This yes. It's a bat quality. Hmm? Yes. I do not have the file. It's a VAT quality video, but I think this helps in explaining, right? You still have questions? Anyone else has any other question?
Hi, I have a question.
Definitely.
I have a question.